I mean, it does form above the node, but it kind of occupies an area about it, around the node.
Doubling up a bit.
And when you have a very large wavelength, like the bigger plates allow for a larger area for the sand to collect, the smaller plates for a smaller area.
Yeah. Now the plate.
Look at that beautiful symmetry, man.
Yeah. The plate characteristics do have some factor. Now these are transverse waves that are on the plate. These are not longitudinal waves going through it. That would be an entirely different system. But the density of the plate at certain places, any kinks in it, affects the overall wave pattern, which you'll actually see later on. We'll show you a picture of our other rectangular plate, which does have some sort of deformity that we can't identify, but it's distinctly not this symmetric. And and it seems to be like a density issue, which probably was a result of when it was being made that was causing impurity.
Also a result of us trying to clean the plate. We got our plates, they were really, really rusted up, so we clamped them down to a piece of wood and sanded them down, and when we unclamped them, we noticed indentations from the clamps. Just pumped them a little bit too hard.
Oh, there's one too. Ooh. And you'll want to try to dial in some frequencies? No?
Alright. It's alright.
Okay.
It's not that hard at these high frequencies. Nice. Beautiful. Oh, that one's great.
That one is a good one. Pretty. Let's go a tad higher. And then we got a good one at 119. Another thing that which relates to what's going on right now, I was saying that the amplitude matters in keeping the plate from completely deforming and going out of control. What also matters is the lower frequencies require a very, very low amount of amplitude in order to get them in the sand to settle in the right place. These higher frequencies require a much higher amplitude to do that. That's something we discovered too.
When you're dealing with the wave equation, that actually works to describe the plate too. Dealing with any two-dimensional, three-dimensional wave that you're talking about. I know people have done this before, solved it in quantum mechanics and other, maybe even in mechanics course or a physics 3 course. What you do get at the higher frequencies, they get bunched up very closely together. Not unlike the energy levels of the hydrogen atom, the electron or the hydrogen atom. They get bunched up very closely because you get a lot of degenerate frequencies, and then the frequencies about them are very close. You move from you can jump from like a 0, 0, even at the lower frequencies, a 004 to a 222. I'm sorry, a 024 to a 222. They're about the same, you know. So those different primary node numbers, the PQ and R, I guess PQ and R. In our case, just PQ. You get they bunch up very closely as the hires get closer, as the numbers get higher and higher. Yeah. So your frequencies get very close. So we can jump from literally one frequency to another very quickly at the high frequencies. You want to pump it? What are we at? 1,000?
Yeah, 1093.
Let's get a couple more in here, and so we can give everyone's ears a rest.
Push the amps up higher to get the response.
show you a little bit right now that it's possible to form that hexagon shape. Some nice symmetries in other directions too.
Yeah. This is a good play. We're gonna have to analyze this better.
I like that. Where was that hexagonal shape?
Somewhere in the 700s.
I'll have to remember that, because that one I want to redial up.
Here. Is that it or no?
It's close.
That's pretty close. There we go.
It was much nicer before. But still.
727.
Get to the really, really high.
Really high?
Really high.
I have to pump up the amps for that.
That's okay. Give your ears a rest. Feel free to plug your ears. We're just going to do a few wave patterns in the really high. It's going to be really, really loud. So. Nice flower pattern. You lose.
These are hard to violin.
There we go.
There's one. Have you also noticed something about the sound you hear when we hit a resonance? It vibrates. It goes up, right? The tone, the pitch goes up, or the volume goes up.
That resonant frequency driving the amplitude very high. But it's damped very well by the plate.
Yeah. I'm gonna drop this down. That's getting pretty loud.
All right. I think we're pretty good on this.
Yeah.
Let's move it back.